Hi, folks. Welcome to the Break Key. My name's Henry, and today we're going to get back into the fourth ROM with some strings. Now, if I recall correctly, last time we had variables going on. We were defining new variables. We put together a way to create just a random word or something like that. That's all well and good. We can store stuff in memory. However, it's nice to be able to have our program say things to people, which means that it's nice to be able to do string type of things. Okay, so I've done a little bit of research into the For Standard and what that actually looks like in immediate mode, which is what we're using right now. We haven't even touched compiling yet. So everything we're doing is being done in immediate mode. And believe it or not, there are words in the standards dictionary for the core words that actually do this in immediate word mode. And believe it or not, the base core only has one word that defines a string, and we'll get there. But I'll give you a clue. The name of the word that defines a string is word. At any rate, this is going to be a little bit of a dive into how things work with strings and forth and a few other things like that. And a little bit of refactoring, I'm sure, is going to wind up happening because I've got code absolutely everywhere that needs to be consolidated. So just sit back, relax, follow along, and join me right here in the Break Key. So the first thing we're going to look at is emit. And this is arguably the simplest thing you can do as far as showing characters on the screen. It takes the character code in the character encoding, in the implementation encoding scheme, and throws it out onto the screen. Now, I'm going to use standard ASCII for this. And I'm going to, just like we do with the original Color Computer, with the original Color Computer Basic, lowercase is going to be the light characters on the dark background, or the standard background that we've got right now in the fourth ROM. And uppercase characters are going to have the light background and the dark character. So yeah, okay, all that's going to do is it's going to take this value that's on the top of the stack and print out the character. So this should be relatively simple. And since it's going to be an 8-bit character, the top 8 bits don't matter, so our value that we're going to print is actually going to be in B. This should work. This should very easily work. Hey, it worked. It absolutely works. Now, here's the other thing that I have not done. I have not done any sort of translation on this. So right now, all it's doing is it's using that raw code. So what I'm going to need to do is run some translation. We already know that I'm going to leave this up, and you're going to stay on top because I'm going to be referencing you. We already know that if we go for 20 through, say, this is hex 20 through hex 4F, or no, through hex 30F, 20 through 3F, that's going to be these, but they're going to be inverse video, which is exactly where we want them to be. So that's going to be fine. Now, these are actually the capitals. So I want to do this. have the braces, the pipe. Let's see. That's here. Let me pull up just a regular old ASCII. That's great. Okay. That we're missing utility and 127s, I believe. So 127 is actually not printable. That out. Go in base 16 and let's do a, this should give me nothing. That did nothing. Excellent. Let's try. Now, here's the other thing. I have not implemented printing a tab character or a control or a line feed or anything like that. That's not in emit right now. I will grant you that. Right now, I'm not going to. Let me make that marking here. Let's see. Emit worked fine. Let's see. So I want to look. Are we in the numbers and such? That gave me a space, which it's absolutely supposed to do. Yep. Let's go with 21 emit. Good. Beautiful. And all right. That should be correct. 39 is 9. Good. What about 3F? Doing that correctly. All right. At sign, which looks good. Good. All right. That is good. And that's going to be. Yep. Yep. Now, at this point, I should see. We're going to go with 5A and 5B. Lovely. That's what I wanted to see for that. That doesn't look right. 61 is supposed to be. That's supposed to be lowercase a. So that should actually. Oh, okay. So I actually need to subtract 60 from that. Good. But otherwise, it looks fine. So we're at 61. And well, that doesn't look right. Oh, let's try setting the correct base, shall we? All right. And let's just go ahead and send that. And now that one's working. Okay, so that was my problem. Operator error. Gotta love it. All right. Yep, exactly. Not putting anything out there. Yes. Lovely. And that's giving me my graphics characters. Nice. Lovely. Oh, I'm in color set 0, so it gives me a nifty little extra green that I didn't see before, that I didn't notice it was doing. Okay. That's fine. I'm okay with that. All right. So emit is taken care of. I'm going to want to reuse this for when we actually go into printing our strings. You know what? Here's what I'm going to do. All right, so that'll work. And then when we come in to do our string printing, I'm going to want to already have that in B. So we'll just go ahead and come in here and we reuse it and it'll pop us back up to it, no problem. Okay, wonderful. That's good. We've got the emit. One more quick thing. So, ow. In looking at the Forth standard, there's another thing that they do. This little bugaboo called BL. It's a constant. It just drops the character value for a space. And there's the rationale. You can kind of read it. Because the space is used throughout Forth, the standard delimiter of this word is the only way a program has to find and use the system value of space. The value of a space character cannot be obtained with care, for instance. All right. That should be very simple to do. All I have to do is this. And that should take care of it. All right. Now, if I've done that, what I should see when I do a 32, which is exactly what I want to see there. And this is effectively just hard coding a constant into the dictionary named BL. Easy enough to do. So we've got our emit. We're putting a character on the screen. We are also putting a blank onto the stack or a space character on the stack. Great. Now we're moving closer and closer towards actually having strings and string variables. And Forth does something very interesting in the way that the standard handles strings because unlike C, which uses a null terminated string, which if you remember we used in our error messages and to put our error messages on screen, Forth uses the concept of what's called the counted string. Now, there are a whole bunch of what this Forth standard calls data types, and these data types aren't checked. This is the key thing to understand. They aren't checked. When it comes to the parameter stack, the only thing that actually exists on the parameter stack is a number of some sort, and it is a binary number of some bit width not to be less than 16 bits in width based on the standard, and we're doing a 16-bit we're doing a 16-bit parameter stack or data stack implementation. So just about everything is going to boil down to, in some form or fashion, a 16-bit word sitting on the stack. Whether that be your flags, your true or false flags, your characters, which even though a character in ASCII is 8 bits, basically what that means is we're going to refer to an 8-bit character and we're going to ignore the top bits of the 8-bit of anything that's on the stack. We're only going to use the lower, the least significant bits. Unsigned numbers, signed numbers. Right now we're only doing unsigned. We can fix that later. And then the other thing that we've got here is C address, which is character aligned address. Okay. And its size on the stack is 1 cell, obviously. But that character aligned address, as compared to the aligned address, character aligned is byte aligned in this implementation. And then your U is going to be your unsigned number. Now, when we look at counted strings, when we're looking at strings in Forth, it uses the concept of the counted string. Not a string that is terminated with a null terminator like we see in C, but actually a string in memory identified by the address of memory of its length character, okay? It contains a binary representation of the number of data characters between 0 and the implementation defined length for a counted string. Okay, maximum length shall be at least 255. Each byte thereafter is going to contain a character, but the address that we're going to put that at, that address points to the actual count. There is a word that will place a counted string onto the stack, and that is going to be word. So this places the address on the stack. It skips any leading delimiters, parse the characters, delimited by char, in which case we have to have a character on the stack before it'll actually do anything. But once it's done, it contains the parse word as a counted string. Okay, easy enough. We've been doing this, but we've been specifically using a specific delimiter. We've been using the space as a specific delimiter, but we also have not been storing the count of it. So this should be relatively simple to do, relatively simple to look at some of our other code that we're using, such as like, oh, I don't know, the code we use for create, the code we use to process our tokens. And then there's another thing that it needs to know. It needs to place it. Let's see, it doesn't say where exactly it's going to place it, but we need a place to put this. And this is going to be a transient location, a transient region, okay? Which means that at any time, that region can go away. It can be like crufted or something. So I seem to recall that we have this space around between 300 and 400 hex that we're not really using for anything right now. So I'm going to put it this way. We will say so we're going to place that word buffer at when we do word, that's where it's going to put it. The next trick is we need to create the word. so that should take care of it. Now, let's go ahead and try assembling it and see if it works. And then what I'm going to do is look at, let me do this. Before I do anything like that, let me set my base, 16 base, BL, Word, Foo, and then that's going to be, let's just go ahead and dump it because I know there should be, yeah, we'll dump that. Okay, and that should be one item on the stack. All right, so it stopped at breakpoint 1, which means that it found the word, so that much is working great. All right. And then the LBSR A374. If I look at what's going on with, I need my, where are my registers? Here we go. Here's my registers. All right. U is sitting at 7FFE. Let me see if I can find my... Something very odd just happened. I'm not entirely sure what the heck just happened there, but that doesn't look right. That looks very not right. I'm at B0A8. And I don't even think I'm in the right place now. Yeah, I'm definitely not in the right place. Something went terribly, terribly wrong. All right, so let's go ahead and restart this. B007. Okay, I see exactly what I did. That's what I did wrong. Okay, now I see what happened. I missed putting a... Let's see. I need to make sure that that has the marker. That's what I did wrong. Okay. Oh, B got how did B get clobbered? How did that get clobbered? Where did that get clobbered? Oh, that's how that got clobbered. Durr. I need to use A for that in this particular case because A is the one that we don't care about. B is the one that we do care about. All right, let's get this fixed. That would have been a problem. Okay. So that's not a load B, comma X, that's load A, and that's store A. Save that. All right, let's get you running again. Move you out of the way. And we come up with 300, which is exactly what we're supposed to be, what we're supposed to see. Now, with that said, what I should be able to do is go give me a 300, and I should be able to grab it. Oh. There we go. And that comes with a 306 or a 0306, which that 03 is absolutely correct. And it looks like everything's fine. So if I do a 301, 302 at, and dot that, I get a 0F0F, which is absolutely correct. And also understanding that I have not translated this to ASCII yet, which is something that I need to do. All right. So that's that taken care of for the most part. We're not done with it yet because I want this stored in memory as ASCII, not as VDGSCII. Quick aside. I'm going to have to look at whether or not I want to handle this translation here or whether I want to handle it. Hang on. I'm not sure that I'll leave it as is. We'll look at that later. That might be an optimization for later. But I'm looking at the number of translations I'm doing. I'm thinking to myself, there's got to be an easier way of dealing with this. But what I'm doing is I'm using the screen as the buffer, and since I'm using the screen as the buffer, as the input buffer, it makes sense to just go ahead and leave that the way it is and do these translations here. All right, fine, because later processing I want to do in ASCII. So, yeah. Go. So that's all. That should be taken care of. That out of the way. We'll save that, and let's just go ahead and do a send. .768, which is going to be correct. I've got 3666F6F. Excellent. 466F6F. Lovely. All right, so it's in there. It's ASCII. Now, here comes the next bit. Is going to be putting it onto the screen. So this representation that we've got in memory, that's all well and good. but we need to be able to put this representation out onto the screen. And this by and of itself isn't going to help us based on the spec. There's two words that we need to worry about now. The first one that we need to worry about, let's see, usage requirement. No, I don't want that one. First one that we need to worry about is what we call type, all right? So type actually puts a character onto the string. If U is greater than 0, display the character string specified by C address and U, all right? When passed a character and a character is blah, 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 the corresponding standard character, blah, 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 is displayed because they have blah, 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 blah. Okay, yeah. So it's going to display the ASCII characters, but here's the trick. This address right here, that's not the address of like the actual word buffer itself. That is because the word buffer, remember, when we put that together, the first byte of that had the count. This is the count. So we need to drop onto the stack in order for type to do what it needs to do. We need to drop onto the stack not only the address of the first actual character of the string, but also the count of the string. Thankfully, there's another word in the standard library that does that, and that word is count. What we do is we take the character string specification for the counted string stored there, and we drop the address of the first character after that, and then the count itself. So first and foremost, let's work on count. Okay, we've already gone over that. So for count, so what I want to do is 16 base, we'll do that, and we'll do a BL word foo dot, no, we're not going to dot, we're going to dupe dot, just to make sure everything looks good, and we've got foo right there, great, 03, and then what we're going to do is, let's see, we should have depth is 1, beautiful, and I want to count. Okay. Now let's see what U says. U says you're at 7FFC. So if I go down here and look at what's on 7FFC, I've got 0301 and 03. So if I ... 301, bangarang. That's what we're looking for. All right, excellent. So that's taken care of. Now, the next trick is going to be to do our type. And here's where things get fun, because type is going to translate from ASCII to VDGSCII, and we've already got that code written. It's in emit. If I can find emit, it should be right up here towards the top because we just wrote it. There it is. Okay. That by and of itself should just work. All right. I may regret this, but let's go ahead and give it a send. Oh, I didn't put over in. Okay. And actually, I think the other one that I want is to dupe because I want to look at that. Look at those. So we do a quick divert. Well, that didn't work. That went all kinds of wrong. Oh, there we go. That's my problem. Push the user stack, not the system stack, because the user stack has the parameters, and the system stack has the system stuff, like return addresses. Yeah. You'd think I'd be that smart. All right, great. So it's got 301, and I should be able to do a to-do. Why didn't that work? Right. I'm thinking backwards. Lower on the stack is higher in memory. Ugh. Stack pointer doesn't count up, it counts down. That looks more like what I was expecting. And that went absolutely, yeah, that didn't work at all. It tried to, but something went terribly, terribly awry. Okay, so it didn't find its end condition. That much is for sure. And it's also putting a space after every character. Oh, right. That's right. Okay. Emit puts the space in front of the out. Yeah. That's annoying. That's very annoying. All this right here needs to be its own subroutine. Everything else was working fine. Yes! Beautiful! Here's the thing. We got a little bit of a problem with the delimiter comparison because ultimately I want this thing to... No, I don't know. Do I need it to think? Yes, I do. Because I want that to actually be the ASCII code that it's going to use when we're looking at the delimiter because I might just provide an ASCII code. So I'm going to need to translate that, which means that I'm going to need another little subroutine in here, which we've already done in the Word thing where we've put it, let's see, get the loaner character into B, and then we translate it to VGSCI. Because what we're going to do, even though we're going to provide an ASCII character, we're going to provide an ASCII character, we are looking at VGSCI characters because we're using the screen as our input buffer, blah, 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 blah. There we go. Right, so that should take care of that. And what I should be able to do now is this. We were at TikTok, and I should be able to go and put in the next word we're going to look at, which is going to let us use different delimiters. Because one of the big problems in Forth is that it does not really have a way, other than just putting the ASCII value onto the stack as like a raw number. You don't really have a way to say this is a character literal. At least not in the basis of it. There are other things you can do. But if we want to put a character literal onto the stack, there's a couple of ways this can be done. And I believe the first one, the one that we're going to use, is going to be that one, char. See what we did there? Okay. Now, skip leading space delimiters, parse name delimited by a space, put the value of its first character onto the stack. So this is actually going to be relatively easy, but now we're running into that same problem where we've got so many things that are doing the same thing and looking for the space. I've got the same code in 5 different places. I really don't want to do a refactor on that right now because that's just a recipe for disaster. I want to get this working first, and then I'll refactor afterwards. Okay. Char does not require there to be anything on the stack, so I'm not even worried about that. It's going to look for something later in the token string. All I need is that first character at the beginning of the token buffer. So here, that should take care of it. All right, so let's see if that worked. Beautiful. And no, that's actually correct. Lovely. And what I was going to do with that is yes. Well, that didn't work. Oh, I know why that didn't work, because it scrolled over. So that's an error signification that I still need to deal with. Yes. Yes. Nice, it works. Okay, so if I've done this correctly, I should be able to do this. Yes, it's working. Beautiful, lovely, marvelous, absolutely fantabulously wonderful. And now, one more thing, because, of course, we really can't. I mean, that's all great. We got strings, we can print stuff. But how do we save these strings? Right now, they're sitting in a buffer that gets clobbered every time we write a new word. And we can look at the code and see that the word buffer gets clobbered every time we write a new word. If we don't do something with it, it's gone. Okay? So, or put a new string in there, I guess. Not write a new word, because if we're writing a new word, it has semantic differences. But every time we use the word word, we clobber the word buffer. Hey. Buffalo, 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 buffalo. Yeah, whatever. Okay. So the next one we're going to look at, move, address 1, address 2, and U. If U is greater than 0, copy the contents of U consecutive address units at address 1 to the U consecutive address units at address 2. After move completes, the U consecutive address units at address 2 contain exactly what the ones at address 1 contained. We've already got count, which will take which will take that and drop it right onto the stack. Okay, so that gives us that information right there. So I need 3 items on the stack. Now, don't forget, Henry, don't forget. The stack, you add to get to the next one. We're done, so all I need to do, everything's been consumed, everything should be fine. All I need to do is RTS. This should be working relatively simple. And 7FFA, which is correct. I got a 62C, 300, and then I can do the move. There it is. Good. All right. So if I do this, everything's at 8,000. If I do a foo count type. Bang! Working. Yes. There was another thing that I saw that was a little bit off, but we have some success here, and I'm going to call that happiness. Okay, well, this has been a big success. I'm not going to say a rousing success because, well, we unearthed a few bugs that need to be dealt with. But those bugs can be dealt with. They're easy enough to be dealt with, and they will be dealt with. The question is, will I do it on camera or off camera? I'm not really sure. I'll figure that out later. But be that as it may, we now have strings working. We can grab a character. We're translating to and from ASCII to VDGSCII. We are taking care of setting those strings into a variable that's not going to be clobbered every time we try to create a new string. We're able to do that. Everything, it's working. It's doing what it's supposed to be doing. This is good. This is beautiful. We're getting closer and closer to a fully functional programming environment. Although I do need to do something about sign numbers. We'll get there. That's okay. because this has been a wonderful experience, just getting more stuff done. And yeah, it's great. I'm really, really happy. So I hope that you've enjoyed your time right here at the Break Key. Don't forget to like, share, and subscribe. Tell your friends about the Break Key. Tell your enemies about the Break Key. Whatever it is, if you like it, hit the like button. That's always wonderful. Come back again. We'll have some fun right here at the Break Key.